Dear students, today I am going to solve the numericals based on Snell's law, lateral shift and normal shift. Okay?
So ninth question will go now. A light ray is incident on a plain glass slab of thickness T at an angle of incidence I as shown in the figure. If m is the refractive index of glass, then find time taken by the light ray to travel through the slab. So see the diagram carefully. What is the thickness of the glass slab? T, and refractive index is m or mu, and here is light is incident on the surface by making an angle. What is that? I with the normal. So angle of incidence is equal to I, and is refracted by an angle of what is that? R. And to travel the distance d, we need to calculate the time taken by the light ray. So there is nothing but time taken by the light ray to travel through the glass slab.
So now we will see the solution of ninth question. This is the one slab having refractive index. What is that? Mu. And the light is incident on this slab by making an angle I with the normal, and the light is refracted like this. As it enters into the denser medium, it bends towards the normal. So what is the angle of refraction here? R. To travel this distance, this is the t, the distance travelled by light in a given medium. This is the t. To travel this distance d, how much time required by the light? Okay, we need to calculate time taken by the light to travel this distance d when the incident by making an angle I with the normal. Not normally, by making an angle I with the normal. In my previous class, I explained that the light is incident normally, then time taken to pass through that I explained. Now, this is by making an angle I with the normal. As we know that velocity of light is equal to here distance travelled divided by time. We want time. Time is equal to distance divided by velocity. As we know that from refractive index of medium is equal to velocity of light in vacuum divided by velocity of light in a given medium. Now, velocity of light in a given medium V is equal to C divided by mu. This is from these two we can write time is equal to distance travelled divided by, here V is equal to C by mu. This is equal to mu d divided by c. This is the time travel, means time taken by the light to travel distance d. But here r is mentioned and d, just I mentioned d, we can write in terms of what is that? Further this. Time is equal to, from this diagram, cos r we can take. Okay, so cos r is equal to adjacent by hypotenuse. Adjacent means what is that? This is the thickness of medium t, and this is the hypotenuse. This is t divided by d. We want the d now. So d is equal to t divided by cos. So in the place of d, we can write. So time is equal to mu into t divided by cos r divided by c. This is equal to mu t divided by c into cos r. This is the time taken by the light to travel d distance when it is incident by making an angle I with a normal on the surface. Right? Got it how we calculated? Like this.
Next, problem number 10. light of wavelength 4500 angstrom in air is incident on a plane boundary between air and another medium at an angle 30 degree with the plane boundary. As it enters from air into the other medium, it deviates by 15 degree towards the normal. Find the refractive index of medium and also the wavelength of given light in the medium. So what we need to find? Refractive index of medium and the wavelength of light in that medium. So wavelength of light in vacuum, that means in air they have given, that is a 4500 angstroms, and angle made by incident light. See the diagram, angle made by incident light with the plane boundary, nothing but surface, is 30 degree. That is not the angle of incidence, so we need to get first angle of incidence I. And the refracted ray is deviates by 15 degree towards the normal. That is not angle of refraction, that is angle of deviation. Okay.
Next, 10th question, solution. From the question, this is the angle made by incident lights with the surface, not with the normal. And they mentioned that it deviates towards the normal by 15 degree. Deviates towards the normal by how much? 15 degree. They mean that it makes 15 degree with the normal. See, understanding is different, no? So here, a light ray incident on a surface which is separated to media and makes how much angle? 30 degree with the surface. It is making 30 degree with the surface. It is nothing but angle of glancing. Then this angle, this is 90 minus 30, how much it is? 60. So angle of incidence is equal to how much? 60 degree. And here, this is the angle of deviation. What is meant by angle of deviation? I have explained the angle made by refracted ray with the direction of incident light is known as angle of deviation in the case of refraction. So this is angle of deviation, and this is 60 means this is also 60. Then this particular angle, that is that angle of refraction. This angle of refraction means 60 minus 15, right? This is total 60 and this is 15, and R is equal to I minus D. R is equal to I minus D. Now this is equal to I is equal to 60 degree minus 15 degree. How much it is? 45 degree. So angle of refraction is how much here? 45 degree. So angle of incidence 60 degree, angle of refraction 45 degree, and lambda in the air they have given, that is 4500 angstroms, and we need to get wavelength of light in a given medium. So in this medium we want wavelength. Now from Snell's law, okay, we can apply the Snell's law. What is that? Mu1 sin I is equal to mu2 into sin R. This is the refractive index mu1, and this is the medium refractive index mu2. Okay. Now this mu1 is the air, so its refractive index is equal to 1. So sin R divided by sin R is equal to mu2 by mu1. Now sin I is equal to how much? 60 degree, and then sin I is equal to 60 and R is equal to 45. So sin 60 degree divided by sin 45 degree is equal to mu. So I can take mu2 by mu1. mu1 is equal to 1. mu2 is the refractive index of that. So simply I can take a mu. So sin 60 value how much? Root 3 by 2. Sin 45 value 1 by root 2 is equal to mu. From these two, okay? This is root 3 by 2 into root 2 by 1 is equal to mu. 2 we can write root 2 into root 2. 1 root 2 can cancel, remaining one more root 2. That is square root of root 3 by 2 is equal to mu. So mu is equal to under root of 1.5. Square root of 1.5 value 0.2247. This is the refractive index. But we want what is that? Wavelength. Wavelength lambda dash is equal to lambda divided by mu. As we know that it is inversely proportional to refractive index. Lambda dash in the medium is equal to in vacuum divided by refractive index. So lambda is equal to here 4500 angstrom divided by mu is equal to 1.2247. This is equal to 3674 angstrom. So this is the wavelength of light in a given medium. From where we got from since lovely we have done all these things. So they have given 630, not 60 directly. So first we need to calculate the angles. According to that, we can get the answer.
Next, problem number 11. A ray of light is incident on a glass slab of refractive index 1.5, making an angle of 40 degree with the surface. Find the angle of refraction in glass. Velocity of light in vacuum is 3 into 10 power 8 meter per second. So what is the refractive index of glass slab? 1.5. And how much angle made by the incident light with the surface? 40 degree. So we need to get what is that? Angle of refraction. This is the question number 11.
Next problem number, what is that? 11. A light ray is incident on a surface which is separating two media by making an angle 40 degree with the surface. So 40 degree with the surface. And its refractive index of the medium, what is that? 1.5. Its refractive index how much? 1.5. Then find the angle of refraction. That much only given. So from this, angle of incidence is equal to, angle of incidence means angle made by incident light with the normal, not with the surface. This is 40 and this could be how much? 50 degree. So total 90 degree. 90 minus 40 is equal to 50 degree. So I is equal to here 50 degree. And the refractive index mu is equal to 1.5. From Snell's law of refraction here, mu1 sin I is equal to mu2 sin R. This is mu1, this is mu2 is equal to, that is equal to mu is equal to 1.5. So for A, refractive index is equal to 1. So it is equal to 1 into sin 50 degree is equal to 1.5 into sin R. This is sin R is equal to sin 50 degree divided by 1.5. Sin 50 degree is 0.7660 divided by 1.5. This is equal to 0.5107. 0.5107. Sin R is equal to 0.5107. R is equal to sin inverse of 0.5107. So sin inverse of 0.5107 approximately 30 degrees. So it will be more than 30 degree. So this is equal to 30 degree 43 minutes. So R is equal to approximately 30 degree or 30 degree 43 minutes. This is the angle of refraction. This is also from Snell's law. So I am solving all these problems how to apply the formulae or concepts. Got it?
Next, question number 12. Monochromatic light falls at an angle of incidence I on a slab of transparent material. Refractive index of this material being m for a given light, what should be the relation between I and m so that the reflected and the refracted rays are mutually perpendicular? Here what is the refractive index of material? M. So we can take even mu also, no problem here. So light falls at an angle of, what is that, incidence I, means angle of incidence is I with the slab of transparent material, and refractive index m or mu, either one we can take. And here they are asking that what is the relation between angle of incidence and what is that, refractive index of the material, so that reflected and the refracted rays are mutually perpendicular.
Next, 12th question. A light ray is incident on a surface which is separating two media, here and here, another medium, and by making an angle of incidence I. The angle between these, as mentioned in the question, that reflected light ray and the refracted light ray are mutually perpendicular. So, reflected light ray and the refracted light ray are mutually perpendicular. So, angle between these two is 90 degree. Then, what is the relation between refractive index and the angle of incidence? These two. So, relation between what is the refractive index and what is that angle of incidence. So, we need to get a relation between these two. I here and this is also I. So, it follows the laws of reflection. And this is angle of refraction R. The total is how much? This is 180 degree. From the diagram, okay, 180 degree is equal to I plus that angle between reflected and the refracted, 90 degree, plus angle of refraction. Now we want angle of refraction. So angle of refraction R is equal to 180 minus 90 degree minus I. This is 90 minus 9. So what is the angle of refraction? R is equal to 90 degree minus I. Apply Snell's law. From Snell's law, mu1 sin I is equal to, first medium over second medium, mu2 into sin R. Mu1 is equal to 1 mu into sin I is equal to, mu2 is equal to mu, sin R is equal to, here R is equal to 90 degree minus I. So this is sin I is equal to mu into, sin of 90 minus theta is cos theta. So cos I. Then mu is equal to sin I by cos I. This is equal to tan I. So sin theta by cos theta is equal to tan theta. So that's why sin I by cos I is equal to, what is the tan I? From this, tan I is equal to mu, I is equal to tan inverse of mu. This is the relation between what is that angle of incidence and what is the refractive index of the medium. If the reflected, it means the reflected light ray and the refracted light ray are mutually perpendicular. Okay, so I is equal to tan inverse of mu.
Next, 13th question. Okay, 13th question. A ray of light is incident at the glass water interface at an angle I as shown in the figure. It emerges finally parallel to the surface of water. then the value of mg means here refractive index of glass. We can take mu g also. So see the diagram carefully. A ray of light is incident of the glass water interface at an angle I as shown in the figure. It emerges finally parallel to the surface of water. Then value of refractive index of glass would be. So this we need to get refractive index of what is that? Glass slab.
Next, question number 13. Here, two media is given in here. One is a glass medium, another one is water medium, another one is air medium. So light is incident, means light is first passing through the glass at the boundary which is separating water and the glass. So it is refracted, and finally it is refracted from water to air. So this is from air to glass, glass to water, water to air. So finally the emergent ray is parallel to the water surface. Okay, the emergent ray, this is called emergent ray. This is parallel to the water surface, means perpendicular to the normal. This is 90 degree. And this is angle of incidence, and this is angle of refraction, and here also same angle will be there, angle of refraction. Okay. Now what is the refractive index of glass? If the emergent light ray is parallel to the water surface, then what about the refractive index of glass? So here this is one pair and this is another pair of media. Apply Snell's law for a given pair of media. Okay, just from Snell's law only we will get the answer. Right? Shall we go now? So first I am going with glass and water, further water to air. For glass and the water interface. Applies Snell's law. So refractive index of glass mu g into sine of angle that I is equal to, in water, that is mu w into sine r. This is 1. Next, for water and air pair, mu w sine r is equal to mu a sine of 90 degree. Now simply this one we can take, this is I and it is I dash. So here it is, what is that? I dash. Further we can substitute the I dash value. From 1 and 2, mu w sine r is equal to mu g sine I is equal to mu a sine of. So these two can equate. These two are equal. That's fine. Mu g sine I is equal to mu a into sine I dash. Mu g into sine I is equal to mu a means refractive index of air is equal to 1. Here it is I dash is equal to 90 degrees, so sine of 90 degree. So mu g into sine I is equal to sine 90 degree is equal to 1. So totally is equal to 1. So next further mu g is equal to 1 by sine I. This is the refractive index of glass when the emergent light ray is parallel to the surface of water.
Next question number 14. A ray of light passes through 4 transparent media with a refractive indices M1, M2, M3 and M4 as shown in the figure. The surfaces of all media are parallel. if the emergent ray CD is parallel to the incident ray AB, we must have, this is the question. So, four transparent media are placed parallelly in contact each other and having refractive indices M1, M2, M3 and M4 respectively. And here emergent ray, what is that? CD is there parallel to the incident ray AB. And what we should have, we must have to get this condition. M1, M2, M3, M4 are the refractive indices of these four transparent materials, and among the following four options, which is the valid in order to be CD is parallel to the AB.
Next, 14th question. Okay, like this diagram is given in the question, and this one and this one they mentioned that these two are parallel to each other. So it is in the direction of this, parallel to, direction is same but shifted somewhat. Now, what is the relation between all these things? So, with refractive index of first medium M1, this is the four media are there. Refractive index of first medium M1, refractive index of second medium M2, refractive index of third medium M3, and refractive index of fourth medium is M4. Right? And here, what is the relation between all these things? In order to get this, what about M1, M2, M3, M4 relation and even angles? Observe carefully. This is the one here. It is the angle IB, and here angle, what is that? IC. From the diagram, okay? From the diagram, IB is equal to IC. IB is equal to IC. And here, observe carefully, this is incident normally to this surface 3. From 2 to 3 it is going normally. So normally means it doesn't refract. Even though it is doesn't refract, it may be that M2 is equal to M3. Okay? It may be. So M2 is equal to M3 or M2 is not equal to M3. Irrespective of that, if the light is incident normally, then it doesn't deviate at all. It will pass, what is that? In the same direction. So these two, we can't say M2 is equal to M3 or M2 is not equal to M3. So we need to go relation between M1 and M4. Apply the Snell's law here. From M1, this is the refractive index mu1 into sin IB is equal to that refractive index mu4 into sin IC. How we got? As we know that from the laws of refraction, product of refractive index of the medium and sine of the angle of incidence in that is equal to constant from this. Now mu1 is equal to here m1 sine IB is equal to mu4 is equal to m4 sine IC. Here IB is equal to IC. So sine IB is equal to sine IC. Sine IB is equal to sine IC means m1 is equal to m4. So what is the relation between those m1 and m4? m1 is equal to m4 and IB is equal to IC, and here m2 is equal to m3 or m2 is not equal to m3. Is independent of that, we will go, what is that? Along the same direction, since for normal incidence of light, refraction means deviation is equal to 0. 15th question. Here, this is a spherical surface, spherical refracting surface like a paperweight. So light is incident on this spherical surface or refracting spherical surface by making an angle A with the normal. So angle of incidence is equal to how much here? A. Then what about the angle of deviation finally? So this is the incident light and this is the emergent light ray. Then what is the deviation produced for this? What is that? Emergent light ray. So deviation means angle made by the refracted or emergent light ray with the direction of incident. So this is the angle made by what is that? Emergent light ray with the direction of incident light. This is what? Angle of deviation. And this angle of deviation here, first angle of deviation at during first refraction and angle of deviation at second refraction. So these two things we need to take first. This is the angle of refraction and here also the angle of refraction, and this is A and this is also A and this is also A. Then this is angle of deviation, that is D1, and this is the angle of deviation, that is D2. Now from the diagram, angle of deviation D1 is equal, this is total A and this is B, A minus B. Even D2 also, this is A and this is B, then this is equal to A minus B. Total deviation D is equal to D1 plus D2. This is equal to A minus B plus of A minus B. This is equal to 2 of A minus B. This is the deviation produced by the spherical refracting surface. Got it? And we can replace A and B with the symbols I and R. So angle of deviation produced by the spherical refracting surface D is equal to 2 into angle of incidence minus angle of refraction. Okay.
Next question number 16. A ray of light falls on a transparent sphere with the center at C as shown in figure. The ray emerges from the sphere parallel to the line AB. The refractive index of the sphere is. So see the diagram carefully. This is a transparent sphere having center C, and the light falls on the transparent sphere, and finally the emergent ray is parallel to the line AB. Then refractive index of sphere is. Here angle of incidence is given, that is a 60 degree, and we need to get refractive index of this sphere.
Next 16th question solution. As mentioned in the question, light is incident on a surface. This is a spherical refracting surface. By making an angle 60 degree with a normal, then after refraction it passed along the line AB. So this is the angle of incidence. It is passed along the line AB. So this is the direction of incident light and this is the refracted light. Angle between these two, what is that? Angle of deviation. So here angle of deviation is equal to how much? 60 degree. So as I had explained in the previous problem, that is the problem number 15, angle of deviation produced by the spherical refracting surface D is equal to 2 into I minus R. Okay, now D is equal to how much is here? 60 degree is equal to 2 into 60 degree minus R. Okay, here 2 ones, this is to 30 degree. So 30 degree is equal to 60 degree minus R. We want R. So R is equal to 60 degree minus 30 degree. So 60 minus 30, 30 degree. Why I calculated? They asked what is the refractive index of this spherical refracting surface. So from Snell's law, that is sin I divided by sin R is equal to mu. So here mu is equal to sin of, here I is equal to 60 degree divided by R is equal to 30 degree. Sin 60 is equal to root 3 by 2. Sin 30 is equal to 1 by 2. 2 cancel, root 3. So mu is equal to root 3, that is equal to 1.732. This is the refractive index of this spherical surface. So this formula I have taken from the previous problem, that is problem number 15. Explain how we got D is equal to 2 into I minus R. This is the deviation produced by the spherical refracting surface.
Next question number 17. In a tank, a 4 cm thick layer of water having a refractive index 4 by 3 floats on a 6 cm thick layer of an organic liquid. Mu is equal to 1.5, means refractive index of organic liquid is 1.5. Viewing at a normal incidence, how far below the water surface does the bottom of tank appear to be? So, bottom of tank appear to be, we are seeing normally, means from air, then how far the bottom of tank appear to be? Okay, this we need to calculate. So here water layer is floating on an organic liquid having thickness 6 centimeters and the water layer thickness is 4 centimeters. Total thickness is 10 centimeters, that is a real one. But here we are seeing from rarer and bottom of the tank is nothing but object is there in the denser medium.
Next, problem number 17. Okay, so a layer of 4 centimeters of water is placed on a layer of some oil having refractive index 1.5, having thickness 6 centimeters. So this is a layer and this is another layer. This layer has a 4 centimeter thickness and this layer has 6 centimeters thickness. Then real depth is equal to 10 centimeters. But an object is placed at the bottom of this and you are seeing from the air, this is the rarer medium, object is there in the denser medium, then there will be shift in the position of what is that object. Look like, but not physical shift, apparent shift. That apparent depth we need to calculate. So by placing coin in the glass full of water, if the coin is there at the bottom, then if you see like this normally, then look like coin is raised up. Okay, it means that there is an apparent change in the position of object. That is called normal shift. Here, what we need to get apparent depth. Real depth is 10 centimeters, but look like what is the depth of that object. So, since the object is there in the denser and we are seeing from the rarer, then refractive index is equal to, I will explain this formula, okay. So, refractive index is equal to real depth divided by apparent depth. Okay, apparent depth is equal to real depth divided by refractive index of medium. For n number of given pair of media, we can apply the same. Apparent depth is equal to apparent depth due to water. Apparent depth, this is due to water, and plus apparent depth due to liquid. This is the total apparent depth. Apparent depth is equal to real depth divided by refractive index of water. This is due to water layer plus real depth divided by refractive index of liquids. This is equal. What is the real depth of water? 4 centimeter divided by mu w is equal to 4 by 3 plus real depth in the liquid how much? 6 centimeters divided by refractive index 1.5 means I can write 3 by 2. 4 cancel. This is 3 plus 3 1 ja, 3 2 ja, 2 2 ja, 4. This is equal to 7 centimeters. So what is the apparent depth here? 7 centimeters. What is the real depth? Actually 10 centimeters. But if you are seeing from this, it is look like at depth of 7 centimeters only. This is due to what is that? Normal shift.
Next question number 18. A fish rising vertically to the surface of water in a lake uniformly at the rate of 3 meters per second observes a bird diving vertically towards the water at a rate of 9 meters per second vertically above it. If the refractive index of water is 4 by 3, find the actual velocity of the dive of the bird. So what is a fish? Fish is rising vertically upward to the surface of water with a velocity how much? 3 meters per second. And the fish observed that a bird is diving vertically towards the water at the rate of 9 meters per second. This is the velocity observed by the fish of the bird. And we need to get actual velocity of the dive of the bird. This can achieve, this can get with help of what is that? Normal shift.
Next, question number 18. This is a fish bird problem. A bird is diving into this. Okay, a bird is diving from certain heights towards what is that fish, and the fish observe that. This is the fish. Fish observe that a bird is diving towards the fish with velocity of 9 meter per second. That is with respect to the fish. So fish is observing, not real velocity of the bird. So fish observe that a bird is diving towards this with velocity 9 meter per second, and the fish velocity is 3 meter per second. And we need to calculate the actual velocity of the bird. Actual velocity of the bird. So here, assuming that a fish is there at a depth of what is that x. Now this fish is seeing the bird. Bird is not seeing here in this case. So fish is seeing the bird. Bird is there in the rarer medium. Fish is there in the denser medium. So the distance between these two is more than the real distance. Since object is there in the rarer medium and it is to be viewed from the denser medium, then the apparent distance or depth will be more than the real depth. So a bird is there at a height of what is that y from the water surface. It will be look like mu y. Okay, so for this, how we got mu y? So here refractive index is equal to apparent depth. So earlier I have taken real depth by apparent depth. That is, when object is there in the denser medium and it is to be viewed from the rarer medium. Now it is not the case, reverse. Object is there in the rarer medium and we are seeing from the denser medium. So mu refractive index is equal to apparent depth divided by real depth. So apparent depth is equal to real depth into refractive index. What is the original height? Y into mu. This is equal to mu y. This is the from the water surface. In terms of fish, bird is at a height of what is that? Mu y. Now total depth from here to here, that is h is equal to x plus mu y. Fish x is the depth is there and the bird is there, look like mu y. So differentiate this equation. dh by dt is equal to dx by dt plus mu into dy by dt, since here mu is constant. What is this dh by dt? Velocity of bird that is observed by the fish, not real velocity. So this is 9 is equal to, what is the velocity of the fish? 3 plus refractive index into dy by dt. Y is the original height of the bird. It means that velocity of bird, this is 9 minus 3 is equal to mu into original velocity of the bird. 9 minus 3 is equal to 6. 6 is equal to mu into Vb. So 6 by mu is equal to Vb. Here 6 by refractive index is equal to 4 by 3 is equal to Vb. So 6 into 3 by 4. 2 2 ja, 2 3 ja, 3 3 ja 9. 9 by 2 is equal to Vb. 2 1 ja, this is 4.5. So Vb is equal to, what is that? 4.5 meter per second. So what is the velocity of bird here? 4.5 meter per second. This is the original velocity of the bird which is diving towards the fish.
Next, 19th question. A parallel sides glass slab of thickness 4 cm is made up of a material having refractive index square root of 3 When light is incident on one of the parallel faces at an angle of 60 degree, it emerges from the other parallel face. Find the lateral displacement of the emergent beam. So here angle of incidence is 60 degree and refractive index is root 3, and we need to get the lateral displacement of the emergent beam.
Next, question number 19. As per the question, what's the thickness of glass slab? 4 centimeters. Okay, this is the medium. And what is the thickness of this? 4 centimeters. And here refractive index of this slab is equal to root 3. And angle of incidence is equal to 60 degree. And we need to get what is this x? X is called lateral shift. When light passes through a rectangular glass slab, then it will be shifted laterally by some distance. The emergent ray is shifted by some distance laterally. This is called lateral shift. And lateral shift formula x is equal to t divided by cos r into sine of I minus r. This is the angle of what is that? Refraction. Okay, from this t is there, yes, I is there, but r not there. So we can apply the Snell's law. This is mu1 and this is mu2. So mu1 sine I is equal to mu2 sine r. mu1 is equal to 1 for air media into sine of 60 degree is equal to mu2 into sine r. Here mu2 is equal to root 3. So sine r is equal to sine 60 degree divided by root 3. Sine 60 value root 3 by 2 divided by root 3. Root 3 cancel. This is equal to 1 by 2. R is equal to sine inverse of 1 by 2. This is equal to 30 degree. What is the angle of refraction? 30 degree. Now lateral shift x is equal to t is equal to 4 centimeters divided by cos of how much? 30 degree into sine of I is 60 degree minus r is equal to 30 degree. This is 4 divided by cos 30 into sine of 30. Sin 30 by cos 30 is equal to tan 30. Or apply the values individually. 4 divided by cos 30 value root 3 by 2 into sin 30 value 1 by 2. So 2 ones are here, 2 2s. This is equal to 2 into 2 by root 3. This is equal to 4 by root 3 centimeters. So what is the lateral shift here? 4 by root 3 centimeters.